section 7 is all about functions and what they are and the definitions. So the first one is a relation. Well, any set of ordered pairs is a relation. So 99.9% of the time, if I ask you if it was a relation, you will say yes. What is a function? Okay, that is a correspondence such that each input corresponds with exactly one output. Okay, so this is the really important part, only one output. And that was the visual I gave you in class about the candy machine. Okay, so keep that candy machine in mind today. We also are going to talk about domain and range. Okay, domain is the independent variable, which is your x, and the range is the dependent variable, which is your y. So let's go through kind of a little more visual for you. Okay, so we're going to think of it as machine like we already talked about. The numbers going in are your independent variables, okay, which is also your domain. So numbers going in are independent, which are your domain, which are your x's. You put it into the machine, the function comes out as the dependent variable, which is the range, which is the y's. So if I picked something like y equals 3x, if I put in 1, okay, 1 for the x, 3 times 1, 3. If I put in 3, 3 times 3 is 9. If I put in 5, 3 times 5 is 15. So for each input, I have exactly one output, so that is a working machine. If we put two different numbers in, we should get out two different answers. Therefore, one number cannot give two different answers. So again, that's the whole candy machine idea, okay? You can plug in you can pick two different things from the candy machine, you'll get two different candy bars. If though you walk up to a candy bar, you hit A5 one time and you get a Snickers, and you come back 5 minutes later and the next time you hit A5 you get a Twix, that's broken. Okay, so something that would look like that, let's say in math world, let's say you plugged in a 1, the first time you got a 5, and the second time you got a 2. That's broken. Okay, it would work, however, if I plugged in 2 and I got a 1, and then I plugged in a 5 and I got a 1. Okay, remember we talked about it like a popular button on a candy machine, each having, you know, more than one, so I could plug in A5 and get a Snickers and B5 and get a Snickers because they would both work. Okay, so we're still working with that idea. So things are going to look like this. Is this a relation? Yep. Okay, because it's a set of ordered pairs. So anything that has a set of ordered pairs is a relation, so almost everything. Okay, then the more tricky questions, is x a function of y? Okay, now when it asks you that, you need to look at the second variable first. Is it a function of y? So I'm going to go ahead, I'm going to take a look at these y's. I'm going to look at the inputs, 15, 10, 5, 1, 5, 10, 15. You can see there are repeats. So then I'm going to see what happens. Well, 15 first went to -3, and then 15 here went to a +3. So 15, I'm visual, so I'm going to draw that out. 15 went to a -3, and then it went to a 3. Well, that is not a function. That is a no, okay, because you had one input going to two different outputs. So that is broken, okay? However, if we take a look at the next question, which said, is y a function of x, then I'm going to look over here on my x's first. I've got -3, -2, -1, 0, 1, 2, 3. Okay, none of those repeat, which means I don't have any problems. Okay, so this is a yes. And we're going to say because each input had exactly one output. Now, some of you may be wondering, but what about -3 going to 15 and 3 being matched up with 15? Well, that is okay. That was like having two separate buttons for popular candy, okay, giving me both the Snickers. That is okay, because when you draw that out, that looks like -3 going to 15 and 3 going to 15. Okay, they don't overlap like the previous one did, so that is okay. Now we're going to talk about domain and range. Okay, domain is independent, so that's the x. Okay, so in my x's, I'm just going to list them. -3, -2, -1, 0, 1, oopsies, 2, 3. Okay, so you list them in the brackets in increasing order. The range is the y's. Okay, so in my brackets in increasing order, 1, 5, 10, 15. Now you're going to notice I did not list them twice, okay, and I list them in increasing order, okay? That is the accurate way to do it. Do not write them twice, okay? So there's example A. Example B, okay, another set of ordered pairs. So yes, this absolutely is a relation, okay? It's just not written in a table this time. Okay, so is x a function of y? Okay, remember you always start with the second variable first. So you can take a look at my y's, 5, 9, 10, 8, 11. Do any of those repeat? Nope. So it is a function. Okay, there's no problems if they don't repeat. So yes, and we'll say each input has exactly one output. Okay, and you'll have pretty much that same reason for every time you say yes. Okay, the only time you have a difference is maybe a no. So let's see what this next part says. Is y a function of x? So now we're going to look at our x's first. So 3, 6, 3, 8, 10. So I see that 3 is repeated, and then I notice that 3 went to 5 the first time and 10 the second time. Okay, so that's a no. Okay, that's not a function. 3 cannot have two different outputs. One input cannot have two different outputs. Okay, I can't get two different candy bars from the same button. So that is a no. Okay, and you don't need to explain any further than that. If you wanted to say one input has two different outputs, that would be okay, or you can simply just show me this. Okay. We can also use the vertical line test to determine if a graph is a function. So if we don't have the ordered pairs, we can also look at it visually. And the rule here is a vertical line cannot intersect the relation in more than one spot, okay, in order for it to be a function. So what that means is, let's say my graph was a circle. If you draw a vertical line through there, that hits it twice, so that's a fail. So that would not be a function. Okay, if it just hits it once, then it's a yes. Okay, so we'll take a look at some of those. Example C says, take a look at y equals 1/2 x squared minus 1. Well, we know a relation is a set of ordered pairs, and if I graph that, that'd be a bunch of ordered pairs, so this is yes. Set of ordered pairs. Okay, so if you can graph it, it's also a relation. Okay, now I want to see if it's a function. So I would like to use the vertical line test because I don't have a set of data. Okay, well, I know what this graph looks like. You probably don't, so you will probably want to use your graphing calculator to see what that looks like, but that is a parabola that opens up, that crosses down here at -1. For you guys on your calculators, just go to the y equals, type in 1/2 x squared minus 1, and then hit the graph button and it should show up. Just remember to put 1/2 in parentheses, okay, so that it reads the fraction correctly. So if I take a look at my graph over here, if I draw a vertical line through there, it only crosses once. Okay, one cross is a pass. So this is, yes, it is a function, and you are going to say because it passes the vertical line test, and you can absolutely just shorten that to VLT. Domain and range gets a little trickier when we just have an equation, so I want to remember that domain is the x variable. The x-axis moves from left to right. So I'm going to start on the left side of the graph, and I'm going to move to the right. So if I start, let's say x marks the spot, I'm going to start over here, and I'm going to look at my graph going in this direction. Well, as I move across, I notice that I'm going to see the graph everywhere, which means I have x values everywhere. So what kind of numbers are x? Well, they're all reals. So I'm going to say x equals all reals, and I'm going to use this bold R to stand for all reals. Okay, I can't bold it like a book does, so I just kind of make it a thick R for all reals. Okay, because the domain wants to know what kind of numbers can be put in for x. Well, I see it everywhere, okay, and it should make sense. I can make positives, negatives, zeros, fractions, okay? Any kind of number can go into this type of equation and get out an answer. So all real numbers. Now the range, on the other hand, range is the dependent variables, which is the y. So this time I'm going to look at the bottom of the graph and go to the top. So let's say I start down here and I go to the top of the graph. First, I notice that there's a big hole right here. Okay, the graph does not exist down there. I start to see it right here at a y value of -1 and above. So where do you see the graph? Where are the numbers? At a y value greater than or equal to -1. Okay, so what you want to do is write where you see the graph. Okay, where is it? Where is it? Okay, period. There was a hole, so at the y value of -1, so I see it above -1. Take a look at example D. Again, is there a relation? Yep. Okay, any set of ordered pairs. You should be getting really good at that one by now. Okay, is it a function? Well, it'd be nice if I knew what the graph looked like. Okay, again, you can use your calculator, but for now, I'll just show you that that graph looks like this. That's the square root of x. So if I draw a vertical line through there, okay, it's only going to hit my graph once. So that is a pass. So yes, it is a function because it passes the vertical line test. Okay, domain and range are the tricky part. Don't worry, you'll get a hang of it. So I'm going to start at the x, which is the left side of the screen, and I'm going to go towards the right. So if I start over here and I look at my graph going in this direction, I don't see it over here. Okay, I start to see the graph right here, which is an x value of 1, and to the right, I'm sorry, an x value of 0. So this time I see x at the positive side, so I see it when x is greater than or equal to 0. And the range is my y's. So this one, you start at the bottom, and then you look towards the top. So now I'll start down here looking at my yellow marker and going towards the top. Again, a big hole. I don't see the graph down here, but I just start to see it at y value of 0, okay, and above. So I'm going to say y is greater than or equal to 0. Okay, these are tricky, so don't get too frustrated. Just hopefully it makes sense once you see the answers, and then eventually we'll work towards you doing it on your own. Okay, but you are writing where you see the graph. That's the main idea. Write where you see the graph. And we'll try one more. Y equals 1 divided by x. Okay, is it a relation? Yep. Okay, set of ordered pairs. That one should almost be a no-brainer by now. Okay, the graph. Ooh, tricky one. Okay, if you graph that in your y equals, it looks like this. Okay, it's called a hyperbola. But anyways, is it a function? Well, this one's kind of tricky. It looks to you maybe like a a vertical line, but it doesn't actually get vertical. It just gets really, really steep. So this still does pass the vertical line test. Okay, so that is a function. Domain, your x's. So I'm going to start over here on the left side, okay, and I'm going to move to the right, and I'm going to say, okay, where do I see the graph? Well, I see it. Whoop, there's a hole, and then I see it again. Well, the hole is at an x value of 0. So I see it everywhere but at 0. Okay, so I'm going to say x cannot equal 0, meaning everything but. Okay, and the range is my y, so I'm going to start at the bottom and I'm going to go to the top. Here I start down here, okay, and I start going to the top. I see it everywhere, but again, I have a hole right here. So y cannot equal 0 as well. Okay, and hopefully this makes a little bit of sense. If you look at the actual equation, I have 1 divided by x. Well, 1 divided by 0 doesn't exist. So that should make sense why x can't equal 0. And if I can't plug in 0, I can't get out 0. Okay, so sometimes you can look at the equation and figure it out as well. Most people just prefer to see the graph. Okay, so take a look one more at example F. Okay, is it a relation? Yep. Okay, set of ordered pairs. Okay, is it a function? Okay, vertical line test. Can you draw a line down here and it just passes once? Yep. Okay, pass vertical line test. Domain, left to right, start on your x's. Start over here. These arrows means this is going to keep going and this is going to keep going. Okay, so as I start over here on the left and I go to the right, I'm going to see it everywhere. So x equals that bold R. Okay, range. Well, start at the bottom. We're looking at the y's. Start down here in the bottom. Go to the top. Because of these arrows coming down, I'm also going to see that everywhere. So y will also equal all reals. Okay, so functions, don't worry too much about them. Well, worry, but know that we will work a lot on them. Okay, and you're going to have many days of practice. Okay, so come with questions tomorrow. Maybe write 1 or 2 down right now, and we can start class tomorrow with questions.